Okay, is this working? Let's try. Is it working? Looks, it should be working now. Let's hope so. Let's check where is the new link. Let's check. Okay, Poppy Seed Dev should be here. Okay, it's live. Okay, cool. So it's live. Is it live? Can I see myself? Okay. Hey. Let's see. Okay, cool. Nice. So finally, I set up everything. I'm sorry for so much trouble with everything. I will just inform you guys that it's live in the Lastic channel. Okay, so what we're going to talk about today. Well, first things first, Polkadot. So let's have a few prerequisites that you need to know before we start this discussion. First, you need to know what's Polkadot. We're not gonna cover the basics here. A bit of development background, maybe not even necessary, but you have to know what's Coretime, and I will try to give you as much context as possible, but some of the basics you have to know. So I'm sorry, this is not for the wider audience, but it's just for the people who know what Lastic is doing and what we are doing. So who are we? We are Lastic. This is our website. Everything is on full screen, so if you go to like the normal computer, you will see everything smaller. It would be nicer. So what are we? We are a Blockspace marketplace. So with the announcement of Gavin Wood, here you can see RFC1, he announced basically Agile Coretime. What is Agile Coretime? It's basically Coretime, allowing Coretime sales on basically Polkadot. So before, how everything was handled, it was, you had basically slot auctions. So people would, every time there would be like certain periods of time where people would just like basically auction their slots. And every you basically auctioned. So each month there was a new slot auction. Maybe you guys who are more deeper into this had some experience with it, and you would basically auction, and there would be different bids on the slot you would get, and then you would get a slot for 2 years. So these bids would go for enormous prices. Let's look at it. Slot auctions, Polkadot. Auctions and crowd loans on Polkadot. Maybe I can check this one. So these prices are actually went for enormous rates. Purchase locked auctions, where is the links? Okay, doesn't matter. Slot auctions on demand parachain. For a parachain to be added, it must be inhabited. So yeah, basically you would have this, you would just buy a slot beforehand for 2 months, 2 years, which is, well, it's not really allowing new teams to come into the space. Basically, if you would imagine, you would have to gather $1 million or something like that, and actually you wouldn't have to pay for it, but lock this dot for that amount of period of time, which, I mean, dot like unappreciates in value, and you would still lose quite a lot of money, and it wouldn't allow you to just basically come in, test the functionality, basically just connect your parachain and disconnect it, and that's it, right? But now we have RFC1. this is a short article I wrote. It's basically just makes it easier to understand what's going on. I will link it down in the article description in this video. Actually, so what is RFC1 about? So this is here. If we check, where is this? So we are in the Polkadot Fellows, and Polkadot Fellowship, for those that you don't know, is basically the fellowship that allows Coretime developers, core developers, to ensure that the protocol of Polkadot is running as it should, and it aims to be as decentralized as possible. Decentralized, of course, it's a hard thing to achieve, but it's one of the more decentralized things. So RFCs, what are RFCs? RFCs are proposal for the changes in basically in the protocol level, and you can basically propose any change that you want. So if we check this text here, you can see many changes, and the first one, the most notable one, made by Gavin Wood, is Agile Coretime. So what does this tell us? So, summary, this proposed a periodic sale-based method for assigning Polkadot Coretime, the analogous of Blockspace within the Polkadot network. The method takes into account the needed for long-term capital expenditure planning for teams building on Polkadot, yet also provides a means to allow Polkadot to capture long-term value in resource which it sells. It supports the possibility of building rich and dynamic secondary marketplace to optimize resource allocation and largely avoids the need for parameterization. So basically this goes on in a really high level language, talking about that before we had these lot auctions. It wasn't much scalable, but now we try to have basically buying Coretime in a periodic monthly basis. So there's a lot of details here, and we're gonna try to break everything down. This is gonna be much more technical than maybe you're used to. So let's see, but I will try to break it down anyways. So now basically how cores are being sold, it's on a monthly by monthly basis, and each month represents one region length, and the price fluctuates over time. So, and we can, so basically, and not only you are able to buy a core, but you're also able to renew it. So I'm gonna try to show you the Streamlit application and simultaneously go and explain to you the details over it. So this is like the Streamlit application I created. Basically tries to check the Coretime pricing over time. Okay, so maybe there's some problems with how the actual code is implemented, but we're gonna basically be checking that. First of all, how this code was made. I went to basically Polkadot SDK. If you go to, so this is the main repository for Polkadot. If you go to Substrate and then try to see frame, you have here the broker pallet. So the broker pallet is the main pallet that has to do everything with agile Coretime sales and everything. So if we go to source, lib.rs, basically we can see all the functionality that this palette provides. And it's pretty cool. And we're gonna be, Lastic is gonna be basically trying to create a layer on top. So this will be all abstracted. So what I try to do is basically take the core functionality, take the core code here that is involved in sales, in purchases, and try to like simulate over time how the price goes. And if we go to the basic the basic code here, I'm running it from the Git. Oh yeah, also you can also do a pull request or something like that if you guys want to change something. By the way, go to Lastic price simulation, and this whole repository is meant to be for everybody in the community, and it's meant to be a tool that just, well, first helps visualize the Coretime pricing, but also aims to be the tool for price prediction in the future, for trying to see if there's some bugs in the code itself, and try to envision how we can change it, maybe, possibly, or basically just see how it will, how much how much core time will cost you. Simple as that. So yeah, feel free to basically clone the repo, and should be pretty self-explanatory how you can basically look at the code. First, you clone the repository, set up a VNV, virtual environment, install the required packages, and basically run it with the Streamlit. So what is Streamlit? Streamlit is pretty straightforward. It allows for Python-based applications. Wait, let's go to the main website of Streamlit. It allows for Python applications to run, to basically have a browser, and it allows to do that like fairly quickly. Yeah, so if we check here the main code, it's pretty self-explanatory and pretty simple. You can see there's not that much code. However, it was able to generate a whole application. Why did I use just JavaScript? Well, because this was much easier to do. And Python is really good for simulation of different pricing and stuff like that. Okay, how should we continue? So maybe let's go a bit over the whole pricing simulation. So let's explain how the core is supposed to be solved. First, let's put a bigger timeline. X-axis. So you just do it by this. So we have a bigger observation time. I tried to set it so you have X-axis here and Y-axis here. And then you can also adjust starting price and so on. So each period, first let's go like this. Each period from red line to red line represents a region length. This doesn't represent when the core is utilized, but it's basically the period in which the price can be sold or not. So basically, if I'm not mistaken, I have to check the code again, but the utilization period comes only from the green line to the green line. I have to check this in the code. So how this works? First, we have a renewal period, which I'm going to come back to. So the renewal period is from, or so-called interlude period. So interlude period or renewal period is between the red and the yellow line. Let's make it a bit smaller so you can see. So it's between the red and the yellow line, and this is basically, how you say, the time where you have the time where each parachain has the time to renew their their core. This supposes that you basically, so if we try to renew it in this period, it supposes that you bought a core in the previous region. And now you're just basically, how you say, prolonging it, right? Then we have the lead-in period. So the lead-in period, as you can see, it's basically, it drops. Let's give it a normal price of 1,000, so it's a bit easier. I made this too. I'm just gonna restart it. Okay. So the starting price for the starting price for the course is still discussed, and we don't know yet what it will be. However, one of the proposed values was basically around 1,000 USD. And of course, this will fluctuate a lot based on the demand. So how it works. First, we have in the lead-in period, which is from the yellow to the green line, we have anybody that is new, comes in and wants to buy the course. So the price goes really high to 2,000, so it's double the price. Actually, here I would put it even higher. Here you have the ability to actually adjust this factor. Let's say we want the current value to be exponential and we want the factor to be like much higher. This is not how the code is implemented, by the way. Just these are new features that could be possibly implemented. So the price drops drastically down, and in each block, it's basically is lower. So the more the more time you give it, basically the more time you give it when you're not buying. So if you're buying it more towards here, it will be easier. Basically your price will be cheaper. However, you might be priced out. For example, if there's a lot of demand, if you expect for there to be a lot of demand, it would make much more sense for you to buy somewhere on the top, because you would be competing with other people who would want to buy the parachain itself. And so, of course, it's best for you to buy it and in the lowest price possible. So, okay, so this is the region land. And then the price stabilizes and it is basically constant. However, this already represents the utilization period. Okay, so let's try to play around with this a bit. As we've seen, okay, this factor curve is not so important. So let's say the starting price is higher. That just puts everything a bit higher. Let's adjust the starting price to be lower. It puts everything to be lower. That's it. Okay, now it's set in 1,000. What else can we do here? We can adjust how many cores are renewed in each sale. So if we put this number way high up, we can see that this rises over time. Let's just adjust the x-axis so you can see. So, for example, now we put cores that are renewed in each sale are, for example, 21. 21 cores are renewed in each sale. That means 21 people have bought the cores before, and they're just, every time they're renewing it. Here, 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 and so on. Then we have cores sold in each sale, which can be basically up to 29 in this case. So we set all the possible cores are 50. I will show you the configuration values afterwards. We can also change this. However, we know from some factors that there will be 50 cores sold. So cores sold in each sale are now 17, and as you can see, the price quite quickly rises in an exponential sort of way. Let's say the observing time is even bigger, so we rise up to 200,000 from 1,000 that we started with. Or what is this? 150,000. Okay. So that's quite a steep, right? And especially here, so one of the few things that I supposed is that we are always buying the new cores in the lowest price. If you would buy it, for example, if you would buy the new course somewhere here or here, this would rise even quicker, if I'm not mistaken. But correct me on that, please. Okay, so next up. But wait, maybe I'm mistaken on this. Let's check the code really quickly. So here's the observing time, x-axis. How is this called? Oh, okay. Cores renewed in each sale, cores sold in each sale. So let's check cores sold in each sale. So this is this factor, and it influences the price. Price is here. Ooh. By the way, I'm not sure if you're able to actually see anything. Hopefully you can see it now. So this is the main function for the main class for calculating the price, located here. Okay, so we have the calculate price. This is the main function. So price calculator dot calculate price. The regions, it's basically calculated when the region starts and what is the current block now. And it works like this. So if the region start is between, so if the block now is between the region start and region start plus self-config region length. So if it's not here, it raises a value error. If the region is between, so red and yellow, this is renew price, and it goes to the renew price function. And if the region is between, and the block now is between the yellow and the green, it goes to sale price calculate. Sale price calculate is here. So you can see self and region start. Block now minus region start. That's our number. And here we go for opt-in for the linear leading factor. And at each new block, when it's renewed, this changes. So this is basically this function now, calculate price, influences only this. So within this one region length, how the price changes. If we want to know how the initial price changes between this region length and this region length, we have to look into another one. So start price calculate, it's this one, this function here. So this calculates the starting price for the upcoming sale based on the number of cores sold. And here I put it a little bit like this, because there is a difference if you buy cores in the renewal period and if you buy cores in the sale period. Mostly, this difference influences the cores bought in the renewal period. So here we can see if the self.cores, if the cores sold are bigger, exceed the ideal price of the ideal amount of cores sold, then this purchase price is basically changes to self.sellout price. Else it's self.price. So purchase price changes, and then we use linear.adapt price. So let's check the linear function. Where is it? Poly. So this is the main function that actually changes the price from one region to another region. So we have adapt price, we have sold, target, and limit. So when the sold amount is smaller than the target amount, the max amount of cores that are sold are you take what is basically the sold amount divided by target, and then basically it goes down and this goes up. That's it. Okay, I'm gonna show you now a bit more advanced features. So we have the configuration values. What do configuration values do? So you have the ideal bulk proportion, which is mentioned in the RFC. Everything here is actually can be seen in the RFC and I tried to name it kind of the same. So ideal bulk proportion. Ideal bulk So they have it a bit differently named, but in the code of the broker pallet, it's called ideal bulk proportion. So how it works, you have the bulk target, bulk limit is 45 as suggested, and then the bulk target is 30 as suggested. Or around, what would that be? Around 60%. So if you imagine it, if in each sale you basically sell more cores, even if this particular sale you sell more cores than expected, the price should naturally like go higher, right? Here. So let's see. Yeah. So here in this situation, if the core in this region, if the number of cores that were sold in this region length exceed the amount of cores in basically this region length, so we have if the amount of cores that are sold exceed our target, then the price rises, right? And it rises proportionally to how many cores we sold. So if we sell all the cores, it rises like really quickly. If we sell them around, let's try to put it so around, currently our ideal bulk proportion would be around 60%. So that would mean here we are just underneath it. And here we are just above it. And here we are exactly how it's supposed to be. So as you can see, we are always on the ideal bulk proportion. Nothing changes much, right? We are always constant. And that's how it should be, basically. However, if there have been more cores sold, and the price exceeds really quickly. However, if there like much less cores sold than expected, well, then the price drops. And it can drop really, really quickly. As you can see, here we have only, 0 cores sold. The price drops to 0 quite quickly. And, well, let's see how many people will be renewing the cores. But actually, that's quite makes sense, right? If you imagine nobody buying the cores, well, the price should drop down to 0. So it's adjusts to the value how much demand there is. Now let's go further. So here in the configuration values, this is a bit more advanced. Let's put it into a reasonable price. Let's say not there 22 new cores just being renewed. That's, by the way, not so good for. Hopefully most of the cores will be sold. So let's see. So the ideal bulk proportion is now 60%. If we adjust this, let's say it's now, let's put it to 20. Press enter. You see, now we're actually around the ideal price. And if we put it around 0.5%, yes, can you, okay. It still basically rises. I'm just gonna put this to 19. Okay, this is one of the vulnerabilities that actually I want to talk about as well. But I will mention it a bit further. So if you see, now we have like the ideal bulk proportion around 20%. And the cores sold in each sale are around, 19? So the price rises quite quickly, right? And even though they're only basically 11 cores sold, the price still rises. So this is actually good to be around 60%, right? So now what is the next thing? Because we want the most amount of utilization, the most amount of cores being sold as possible, right? This is actually quite good. Now we have the leading length. This, according to RFC, by the way, is 20. So leading length period, it's 7 days. I'm gonna say, why is it so different than it is here? Oh my God, I'm going to close these tabs. Okay. So why is this 28 and not 8 as you seen here? It's because I have this value, blocks per day is equal to 4. Let's put it to 1 now. And you should see a difference. So you see why I just put 4 there, because I just wanted like a bit higher resolution. So yeah, if we get, we have now proper factors. So interlude length is 7, leading length is 7, and the region length is 28 as proposed in the RFC. So yeah, so we have bulk period, 28 days, interlude period, 7 days, leading period, 7 days. However, I'm just gonna, let's put it to 4 or 5. I'm just gonna raise this number a bit so we have a bit more higher resolution on the price. Okay, so if we adjust the interlude length, what happens? The interlude period from red to yellow just changes, right? Easy enough. Oh my God, what I'm doing. So, okay, let's put it back to what is supposed to be 35, right? Now let's adjust the leading length to be higher. And as you can see, it goes proportionately down and it stays just, basically it goes down still linearly and until 1000. Now we have how many cores have been offered and so on. Region length, it just adjusts this. So I'm sorry, you cannot see my hand. So it adjusts basically the period between two red lines. What's the renewal bump? Okay, that's actually interesting. So what is renewal bump? If we adjust the renewal bump, this only is affected when actually there have been more cores sold over time. So let's observe over a bigger amount, a greater amount of period of time. So here we have 9 region lengths, or 12, let's say 12. So as you can see, the renewal period is, I hope you can see actually this. So the renewal period is from red to yellow, red to yellow, red to yellow, right? And the renewal starts basically rather like we say here, start price of the core you bought. So this is the starting price of the core we bought, not here, but already like here. So here we bought the core previously for 1000. And then now we try to renew it. basically we renew it, and the price goes a bit further up, and then it falls back down. I have to check if this is correct, but we'll fix the code if it's not. The price falls back down a bit, and then we say, oh, we are buying it on the block when the price is cheapest, and then we buy it again. And from this, like, we bought it now for 1,000, and because of the renewal bump of 5%, or no, now we have actually it higher, 15%. Let's put it back to where it's supposed to be, 5%. It goes to, from before 1,000, it goes 1,050, if I'm not mistaken. Yeah, 1,050, and it goes to then 1,150 and something like that. And it slowly climbs up. Which I don't know. Is it supposed to climb up so slowly? I don't think this is actually correct, and we're gonna submit an RFC to dispute this. Because let's look really quickly what happens if we are just renewing 50 cores at a time. We cannot, by the way, you can see, we cannot buy any more cores right now because we bought up all the cores. So somebody buys up all the cores, I don't know, whoever wants. I mean, you are able to, in the end of the day, you're able to sell those cores. So somebody with investing decision wants to buy up all the cores, then wants to hold up on them, create a lot of demand, and sell them, right? But they can basically block the whole network from running. And how can they do that? Well, very simple, actually. They just buy up all the cores, and then the price is going really slowly up. So we have basically 1,000, 1,050, and then 1,150 or something like that, and then it goes. I'm not able to just calculate in my head. Sorry for that. But the point is the price rises too slow, actually. And if you imagine we have 50 cores only, you are basically able to buy the whole thing with 50K. I mean, for a network with 8 billion, which is Polkadot, I don't know what's the market cap currently. If you imagine that you can only spend such a little amount of money to buy up all these cores, it's preposterous in the end, right? So, yeah. So this price slowly rises, and in each region length we get more cores renewed. I think this should be changed, and if we have like 50 cores in each sale, this should be different. I'm not gonna go to more advanced adjustments since they're not working yet properly. However, what else can we talk about? Maybe I'll show you a bit about like the broker palette and the difference between the two codes, and where can you find the different codes. So, okay, this is RFC, and it actually, so you have the RFC, then once it is approved, all the changes are done then in the broker palette, or basically in Polkadot, the SDK in general. And here you can observe, well, the lib.rs is the main file, and then you have all of these different files attached to it. The easiest way to search on how to search on it, I'm gonna show you actually. Let's get my terminal. Hopefully you can see anything. I think this is too small. I'm on the really large screen, so that's why you might have a problem. Can you actually see it right now? Probably it's still a bit too small. Let's try to, okay. Okay. I'm gonna go open new tab. And again. Oh my god. Why does also the window grow? I don't understand this. Probably there's like some stupid command that you can just scale this up without window scaling as well. Okay, never mind. Let's go to this substrate. Polkadot. Do we have? Where is this Polkadot SDK? Ah, I know. Okay, never mind. I was testing this out a bit before, so everything is now mixed. I have it actually in the Lastic UI. Here we are, Polkadot SDK, finally. And I'm gonna go into substrate, so it's gonna be easier. Okay, so let's continue. So the easiest way to find something in substrate is basically going like this. So start price calculate. And no result. Okay. I know there is like the some functionality that I named exactly the same. Initial bot price, renewal bump. Let's check this renewal bump thingy. Here we go. So this is benchmarking. Then we have the price, the famous price cap, which I'm not gonna go into this episode, but next one. So, and then we have the renewal bump. But the main code you should focus on, basically, it's... Let me show you how the code is similar to each other. So we go to poly, and then we have this class linear. And then we have this leading factor at. And this actually function is completely exactly the same as this. Leading factor at, adapt price. Okay, so let me see. So we are in the broker palette source adapt price.rs. Let's put this here. Should we put them in the same tab? Let's put them in the same tab. Okay. Okay, let's go poly. So as you can see, leading factor at. It's very simple. That's it. Ignore this factor. This factor is 1, so it's just, I try to play around with it a bit. And maybe I should actually, I will write a better description. But yeah, this factor is normally set to 1. You can put it higher if you want. But yeah, so what I wanted to say is how you can check the code if it's similar or not. So I tried to extract as many things as possible that just are connected to the price. And if you can check both of the codes, you can see leading factor at, adapt price. This is adapt price. Here I go for another class, which is experimental. It's called exponential. So if you change this curve to exponential, you can see an exponential. How can I see a better exponential? So you see, now we have an exponential. So if you were to adjust this code to similar to this, power of 2 minus factor, then it would be basically the same. That's about it. Okay. So, if you have any questions, post them please down in the comments below. Check out Lastic. Follow us on Twitter. Where is our Twitter? It's here. Lastic Twitter. Follow for more updates and everything. Let me know what you think. I'm sorry for the technical issues I had with this video. And I am sorry if I wasn't clear enough with some different things. We're trying to still learn and improve as we go. Probably there's quite a lot of errors in this application itself. Really, I want you to play around with it. If you want to play around with it currently, the current deployment is on Lastic.Streamlit app. And as you can see, this one looks a bit different, so it has a bit less features. I have to deploy the new functionality, but essentially if you go to Lastic.Streamlit.app, you can see this pricing simulator. So next week, I hopefully will have already a new RFC that goes into the disputes, the changes that we want to see in the pricing. So we won't have that 50K attack on 8 billion market cap network. And I want to show you also what is the price cap that I talked about. How does that work? And this I have probably to spend just 2 hours or something like that just to enable this functionality, and then you will be able to adjust how the cores that are sold vary through time. So that will be quite cool, right? So you will be able to see and adapt to your application. So why we want to put such a huge emphasis on this? One of the key things why we developed this with Lastic was to basically understand how everything works, how the things work in itself. And another key thing that we wanted to basically provide for the community is for this thing to be. So for our application in the end, we wanted to have like a future prediction. So basically, you will know what to expect the next month. I think that would be really cool, right? So I think that's all from me. I hope you enjoyed this streaming podcast or how you say streaming YouTube video. And I will see you in the next episode, and we will go into more details of the code. Thank you for listening. Bye. Enjoy from the Puppy Seat dev channel.